Okay, here's a little note to see how to use an oscilloscope to see if there's a problem with the APM2. I had gotten an email from Andreas. He mentioned he had been having the same problems, that the ESCs somehow weren't arming on startup, and once they got into a bad or a confused state, they just kind of stayed that way. And I was hitting the same thing, and I wanted to make sure it was the problem with the ESCs and that the APM was actually trying to send the signal. So what I did is I disconnected one of the control wires for one of the motors that wasn't starting up, and then I plugged in a servo wire, and on the end I plugged in some leads so that I've got a handy place to connect. I've put the black lead onto the negative, and I've put the white lead onto the signal so that it can measure what signal the APM is sending. Now we're armed, and we're off here, and we can see on the oscilloscope. Oh, by the way, this is the very nice DSO Nano from a Seed Studio. And we can see here that it's about 1.08 milliseconds, and we can see that by measuring the T1 and T2 here, and then we see the delta between the two there. Okay, that's better in focus. See T1 and T2, and then we've got the delta T. So we're gonna start speeding up the motors. Now the front two speed controllers are working great. It's only the back two that aren't picking up the signal. But we can see we increase, and the PWM signal gets big, and we can see that it looks like the APM is working as it should signal-wise. And now if we want to see what the value is, we're going to bump up the T2 cursor so that we're basically measuring from one, the one pulse width, and we see that's 1.76 milliseconds. So that's about what we would expect in the range for the signal. So we can say that probably the APM board is sending the right signal, and all we got to do is figure out how to get the ESCs armed. Andreas has a way that he mailed me that I'm going to give it a try now.